We want to differentiate y is equal to the log of x cubed plus 3x. Once again we apply the chain rule, so we differentiate as if the inside function x cubed plus 3x is just x. So we get 1 over x cubed plus 3x, because if we had log x, the differential is 1 over x. So the basis of differentiating log x cubed plus 3x is the 1 over x cubed plus 3x. But applying the chain rule, we now need to multiply by the differential of the inside function, which is 3x squared plus 3. Just tidying this, we get 3x squared plus 3 divided by x cubed plus 3x. If we look at this expression, the numerator compared with the denominator, if we call the denominator fx, we can see that the numerator is f dashed x. The numerator is the differential of the denominator. This is always the case when differentiating logarithmic functions, and you can see from this example and the ones before why this happens. This is an important feature to note, as it makes it easy when we see this sort of function when we're integrating. Integration, remember, is the opposite process to differentiation, so this is a useful feature to remember in case you come across this sort of function in the integration chapters to follow.